Okay, guys, so we will be discussing multicollinearity and dummy variable regression and logistic regression, and hopefully by the end of today's session, we'll complete multiple regression. Okay, so first, multicollinearity. What is multicollinearity? Right, what is multicollinearity? So, multicollinearity happens when two or more independent variables are correlated with each other and we are not able to figure out which of the two is explaining the dependent variable, right? So I gave you an example in some prior class that multipolarity is like your wife and mother cooking the same dish together. The dish turns out delicious, but since both were adding ingredients and stirring the pot at the same time, you cannot tell who really made the dish tasty, right? So you can't understand which independent variable is explaining the dependent variable better. So we can't find out the individual impact of a independent variable. Okay, guys, are we good? Have we understood this, guys?
Yes, sir.
Okay. So guys, what are the symptoms of multipolarity? How can you detect? Am I audible? किसी का कोई response नहीं आ रहा है?
Yes, sir.
Okay. So see, if you have um, if you have multipolarity in your model, what will happen is that R square will be high, but the none of the T stats are significant, right? So R square is going to be high, but none of the T statistics of the slope coefficients are going to be significant. So what does this mean? Guys, what does this mean? This means that the independent variables, they collectively explain the dependent variable, but their individual impact is hard to tell. They can collectively explain. So if you have three independent variables in your model, these three independent variables collectively explain the dependent variable, but how each independent variable individually affects the dependent variable, that is very hard to tell. Okay, and see, what happens is that if there is multicollinearity in your model, the standard error of the slope coefficient, so standard error of slope coefficients SB1 hat, SB2 hat, these are inflated. They are higher than they should be. So if these are inflated, if these are higher than they should be, what happens to the T stat? T stat is basically B1 hat minus 0 by SB1 hat. So if this is inflated, if this is higher, then naturally my T stat is going to be lower. If the denominator is higher, then the T stat is going to be lower. It's going to be small. And if the T stat is small, it might be smaller than the T critical. And if it is smaller than the T critical, then we might fail to reject a false null, right? So let me draw. So say this is my critical and this is my rejection area, right? So my T stat might fall somewhere here. T stat might be lower number because my standard errors are higher, right? So I might fail to reject the null which is actually false, thus committing a type 2 error. So always remember that multicollinearity results in type 2 error. You fail to reject a false null. Guys, are we good here? Have we understood this? Yes or no? Hello? तीनों बोलो yes या
तीनों
no.
बोलो Yes,
Yes
sir.
या ऐश्वर्य. हेलो.
Yes, sir.
पुलकित. कित नहीं है. Okay, so how to detect multicollinearity? So we need to understand VIF. VIF stands for variance inflated factors. Okay, है पुलकित. हेलो. चलो कहीं. So say our model is something like this. Y0 equals beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus some error term. This is my original regression model. I want to detect whether there is multicollinearity in this model, whether the independent variables are correlated with each other or not. So what I do is I create a new regression where I regress x1 against the remaining independent variables. So I create this new regression where I am going to regress x1 against the remaining independent variables. Now I am going to calculate the R square of this regression. Now if the R square of this second regression is high, then what I conclude is, if R square is high, then what I conclude is that x2 and x3 explain x1. There is some correlation among them, right? If the R square of this second regression is high, this one, then what I conclude is that x2 and x3 explain x1. There is some correlation between them. These are signs of, this is a sign of multicollinearity. Whatever. Okay. Now what you can do is, with this R square, we calculate the VIF for x1. VIF stands for variance inflated factor. How do you calculate this? 1 by 1 minus r square of x1, right? So guys, if r square is high, if r square of x1 is high, so my denominator is going to be lower. If r square is higher, denominator is going to be lower, and the VIF for x1 is going to be higher, right? Please understand this. Uh, if my r square for x1 is higher, then this denominator is going to be lower because this r square of x1 is getting deducted in the denominator. So if the denominator lower, so VIF higher. So higher VIFs are signs of multipolarity. Okay, now what we do is um, we calculate, we calculate the VIF for x2 and x3. So to calculate the VIF for x2, what we are going to do is you regress x2 against the remaining independent variables. Once you've done this, calculate the r square of this regression, then calculate the VIF of this regression, right? If r square is high, VIF is going to be high, right? R square and VIF are positively correlated, right? If R square is high, VIF is also going to be high, and that is going to be a sign of multipolarity. We will say that if R square of this regression is high, then x1 and x3 explain x2. There is correlation among them, and similarly we can calculate the VIF for x3, right? Now there is a rule of thumb with respect to VIF. Now that rule of thumb is that if VIF is greater than 5, then then um, there are signs of multipolarity, but um, it requires further investigation. If, however, if VIF is greater than 10, this is serious case of multipolarity, right? Requires correction. Okay, so this is your VIF. We need to be very aware of this. This is very simple. You regress one independent variables against the remaining independent variables. If the r square of that regression is high, then then um, x1 is being explained by x2 and x3. There is some correlation among them. There are signs of multicollinearity, right? And if VIF is more than 10, serious case of multipolarity requires correction. Guys, any doubts here, please? Guys, any doubts?
No, sir.
There's any doubts?
Aishwarya?
No, sir.
Now, correcting this. Okay, so first is you can exclude one or more independent variables. Second is what you can do is that you can use a proxy. So what this means is that you can replace one independent variable with a better one or a less correlated one, right? You replace the independent variable with a less correlated variable. And third is that you increase the sample size n, right? So these are three ways with which you can collect multicolority. But see, there is this catch. If your main goal is to make predictions and not interpret which independent variable is doing what, then multicolority might not be a big issue. See, if a model has multicolority, it can still give good predictions, even if the individual independent variables effects are not clear. So you can still use the model with multicolority if your goal is to make predictions, right? So this is the case for multicolority. It's over. uh, any doubts guys? कोई डाउट है किसी को?
No, sir.
No, sir.
Then you will start with dummy variable regression. अब सुनो ये बात ध्यान से. So usually independent variables like company size, GDP or interest rate can take many different values. But sometimes an independent variable is binary, meaning it is discrete. It can have only two possible values like 0 or 1, true or false, yes or no. In such case, we use dummy variables in regression. Right? Let me give you an example. Say you are analyzing monthly stock returns and you want to check if January has higher returns than the rest of the year. So what you do is you create a dummy variable called January, which will have a value of 1 if the month is January, and it will have a value of 0 for any other months. So let me give you an example. So say this is this regression y equals b0 plus b1 into b1 plus some error term, right? So b1 is going to equal 1 for January, and for non-January months it's going to equal 0. Okay, so see, how are we going to interpret this? How are we going to interpret b0 and b1 in this regression? Okay, so understand this. B0 is the average return in non-January months, and B1 is how much higher or lower the returns are in January compared to the non-January months, right? So let's say my regression turns out like this. Y equals 1.5 plus 2x, 2d1, right? So now how am I going to interpret 1.5 and 2? So we are going to say that 1.5% is the average return in non-January months. And how are we going to interpret 2? We are going to say that average returns in January are 2% higher than non-January months, right? So say if the month is January, then my returns are going to be, D1 is going to be 1 for January. So my returns in January are going to be 1.5 plus 2, 4. And for a non-January month, D1 is going to equal 0. So my returns in non-January month are going to be y equals 1.5 plus 2 into 0. Now my D1 is going to be 0 because it's a non-January month. So my return is going to be 1.5%. Guys, are we good? Have you understood this? Yes or no? बोलो अभी तक समझ आया?
Yes, sir.
Mehak and the rest.
Yes, sir.
Okay, guys. So say I'll just run this regression in Excel so that you can understand. So this is say January and the rest is non-January. I'm going to run a regression on this, right? So data analysis, regression. On y-axis you keep the returns and your dummy variable is going to be the independent variable. Output range is going to be. So my regression is something like this. 1.82 plus 2.38x, right? 1.82 plus 2.38x. Y equals returns in January equals 1.82 plus 2.38 into x, no, D1, right? So how am I going to interpret 1.82? 1.82 is the average return in non-January months. And how am I going to interpret 2.38? It's the average return. I'm going to say that average return in January are 2.83% higher than non-January months, right? So if I am in January, D1 equals 1, so my returns are going to equal 1.82 plus 2.38 into 1, which is 4.2. And for non-January months, D1 equals 0, so y equals 1.82 plus 0.38 into 0, which is 1. Guys, have you understood this? Any doubts? Any doubts?
No,
Any
sir.
doubts?
Is anyone having any problem? बोलो ऐश्वर्य.
No, sir.
महक. पुलकित.
सर इसमें स्लोप डमी इंटरसेप्ट डमी भी होता है ना?
क्या कह रहे
इसमें
हो?
स्लोप डमी और इंटरसेप्ट डमी भी होता है ना?
स्लोप
सर इसमें 2 फॉर्म्स होती है ना, स्लोप डमी, इंटरसेप्ट डमी।
हाँ हाँ हाँ, वो मैं अभी आगे उस पॉइंट पे आ रहा हूँ. So see, if you have n groups, then you will always have n minus 1 dummy variables. The effect of the group that you leave out is captured by the intercept b0. Right? This is done to avoid multicollinearity. Right? So um, let me explain. In this example, we had two groups. One is January and the other is non-January. Right? So we had two groups. One was January and other was non-January. So whenever we have n groups, we create n minus 1. In this case, we had two groups, so we are going to create 2 minus 1 or 1 dummy variable. And the effect of the group that we leave out is going to be captured in the intercept. So the effect of, we left out non-January. We created a dummy for January, but we left out non-January, right? We created this dummy for January. Whenever we were in January, D1 equals 1. For other months, it was 0, right? So the effect of non-January months is captured by the intercept term B0, right? So this is, so here also please look, B0 is capturing the returns in non-January months, right? So we always create n minus 1 dummy variables where n is the number of groups. And the effects of the group that we leave out is captured in the dummy variable, is captured in the intercept. The effect of the group that we leave out is captured in the intercept. Okay? Any problems, guys? Have you understood? Have you understood this? So let me give you an
So
example.
let me give.
So we are trying to predict a company's EPS in each of the 4 quarters, right? So there are 4 groups or 4 quarters. So how many dummy variables are going to be? How many dummy variables should we create? Guys, there are 4 groups.
There are 4.
How many dummy variables should I create?
3.
3. So we are going to create one dummy for quarter 1, one dummy for quarter 2, one dummy for quarter 3, and we are going to leave out quarter 4, right? We are not going to create a dummy for quarter 4. um, its effects would be captured by the intercept, right? And see, remember, the group or the class that we leave out is also known as the base or reference. Always remember this. Okay, so let me say my regression equation is this: y equals 1.25 plus 0.75 d1 minus 0.2 d2 plus 0.1 d3, right? So equation is of this form. So understand, if okay, so understand this, uh, d1 equals 1 for q1. For all other quarters, d1 is 0, right? d2 equals 1 for q2. For all other quarters, d2 is 0. And d3 equals 1 for q3. For all other quarters, it is 0. Right? And how am I going to interpret these intercept and slope coefficients? So understand B0 is 1.25. So we are going to say that average returns गाइस अगर मैं ऑफलाइन हो जाऊं ना तो मुझे बता देना है. So average returns in Q4 are 1.25%. Now my B1 is 0.75. How am I going to interpret this? Guys, how will we interpret 0.75? Guys, how am I going to interpret this 0.75? Bolo?
The average returns for quarter one are 0.75% more than the other quarters.
No, not other quarters.
No, not other quarter.
The base quarter,
The
Q4.
base quarter, Q4.
Okay.
Because we are not creating a dummy for it, right? For Q4. So B1, B2, B3 are going to tell me how much on an average um, the returns differ from Q4, right? So we are going to say that on an average Q1 EPS is uh, higher than Q4 EPS by 0.75 dollars or percentages. What is the unit? Okay, let me keep it as um, dollars, right? Let me remove the percent. The average returns in Q4 are $1.25, and on an average Q1 EPS is higher than Q4 EPS by 0.75. So the class that you are leaving out, whose effects are being captured in the intercept, that is your base. So all these slope coefficients have been calculated, relatively on a relative basis, right? On a relative basis, that is how much they differ from the class that you've left out, right? How much they differ from the you know class that you've left out, for which the class for which you've not created the dummy. So now B2 is minus 0.2. How am I going to interpret this? बोलो बोलो कोई. Hello, Mehak. B2 is minus
So
0.2.
average
V2
returns
is
in
minus 0.
average returns in Q2 is $0.2 less than Q4.
Very good. On an average, Q2 EPS is lower than Q4 EPS by $0.2, and B3 equals 0.1. How am I going to interpret this? ऐश्वर्या बोल, तुम बोल.
Quarter three returns are $0.1 more than quarter four. Quarter
Yes,
three.
on an average, right? So my base is Q4. So these slope coefficients, they are being they are being reported on a relative basis, right? How much they differ from Q4, right? So the base is basically the group, the class that you leave out, the group, the class for which you don't create the dummy, right? And the effects of this base or this reference class, the one for which you don't create the dummy, is captured in the intercept, right? Are we good? समझ में है? क्लियर? तीनों को क्लियर है? कोई प्रॉब्लम है?
No, sir.
मैं कोई प्रॉब्लम है? पुलकित कोई प्रॉब्लम है?
No, sir.
पुलकित कोई नो सर।
अब नया चलो इसमें हाँ कर ले। तो बहुत जल्दी हो गए तो आज से टाइम सीरीज भी आज ही चालू कर दें क्या? कर दे।
कर
कर
दो
दो
सर।
Yes, sir.
तो लॉजिस्टिक रिग्रेशन, अच्छा, see we sometimes need to predict probabilities, that is probability of default, right? Now probability will be a number between 0 and 1, right? It's going to be again a discrete number. Probabilities are discrete. Discrete means that you can count the number of outcomes, right? um, so we cannot use our linear regression to calculate probabilities, because linear regression is going to give me continuous numbers, right? What is continuous? Guys, लेवल 1 में याद है? डिस्क्रीट, कंटिन्यूस, कंटिन्यूस क्या था? बोलो। You won't be able to count the number of outcomes, right? So linear regression is going to give me continuous, the output is going to be continuous. But if we want to predict probabilities, then we cannot use linear regression. What we need to do is use logistic regression, right? If we want to predict probabilities which are discrete in nature, right? Okay, so you know, linear regression, the forecasted value of y could be higher than 1 or lower than 0, which is going to be an illogical value of probability. Probability is always between 0 and 1, but linear regression can give me values which are higher than 1 or lower than 0. So what we do is to to calculate probabilities, like say we want to calculate what is the probability of default of a particular bond, or what is the probability of merger between two companies, right? So we are going to use logistic regression for that. Linear regression is not possible because linear regression returns forecast continuous data. So what we do is, in logistic regression, we first transform the probability into odds. Okay, so what is the odd? Say if the probability of something is 0.8. Now its odds are going to be p by 1 minus p. That is 0.8 by 1 minus 0.8, which is 0.8 by 0.2, which is 4. Right? So how am I going to interpret this 4? So we are going to say that the odds of this event occurring is 4 is to 1. Right? Now what we do is that we take the natural log of this odd. This is also known as log odd. Natural log of odds is known as log odd. Right? This whole term is known as log odd. Okay, now we take this natural log of this odd and regress it against the independent variables. Okay, now we are not using linear regression here. Please, this is very important. We are not using linear regression. You're not using the OLS method, right? No OLS. No ordinary least square method. Rather, what we use here is maximum likelihood estimate. So you need to know that we don't use linear regression. We use maximum likelihood estimate, or MLE, right? So what is this MLE? Right? See, OLS tries to minimize the sum of squared errors. But MLE is different from OLS in the sense that it calculates the intercept and slope in a way that makes the sample data most probable, right? So it will calculate beta naught and beta 1 in such a way that, you know, they help the regression mimic the sample data. Or they help the forecasted values mimic the sample. Okay. So how I'm going to interpret beta naught of this regression? Bolo? Interpretation of beta naught or intercept. So can I say that if x1, x2, x3 all equal 0, then log odds equals beta naught, right? So the probability does not equal the beta naught. This log odd equals the beta naught, right? The goal is to calculate the probability. So beta naught equals the log odds if all the independent variables equal 0. Guys, are we good with this? Guys, yes or no?
Yes, sir.
No.
Yes, sir.
Now, how are we going to interpret B1? Bolo? So B1 is that if x1 changes by 1 unit, then log odds will change by B1, right? So your probability won't change, but your log odds will change by V1. Your probability will not change by V1, but log odds will. So again, your probability is not going to change by V1. The log odds are going to change by V1. Okay, so how to calculate the impact on probability? Okay, understand this. I'll give you an example of this also. So first, please write this down. These steps you have to write this down. You calculate the probability or the predicted probability using the average values of the independent variable. Right? Then you increase one independent variable. Write this down. These steps would become easier once I explain them. You increase one independent variable by 1 unit. Recalculate the probability. Now the difference in the probabilities that you calculate in 3 and 1 is the effect of that independent variable on the probability, right? So the difference in probabilities that you calculate in 3, so the probability that you calculate at step 3 minus the probability that you calculate at step 1 is the effect of that independent variable on the probability. सो लेट मी गिव यू एन एग्जांपल. ठीक है, स्क्वाइजर का एग्जांपल लेते हैं. ओके, सो दिस इज द मॉडल. इसको स्क्रीन शेयर कैसे, वो स्क्रीन कैप्चर का क्या बटन था guys? Do you know the shortcut for screen capture?
Sir, window shift S.
Window
Shift S.
shift S. So we'll paste it somewhere here. Okay, so guys, so these are my coefficients. These are my independent variables. So we'll call them x1, x2, x3, right? We're not going to confuse it, right? And we are going to calculate the probability of a dividend increase. So my regression is going to look something like this. Log odd equals minus 3.445 plus 0.332 x1 plus 12.33 x2 plus 3.21 x3. Right, now first we'll follow the first step. Calculate the probability using the average values. Right, so ln of p by 1 minus p equals minus 3.445 plus 0.332 into 3.2. 3.2 into it, the average value of x1 plus 12.33 into average value of x2 plus 3.21 into the average value of x3. इसको कैलकुलेट करो कितना आता है. Calculate this and tell me how much do you get.
minus 1.29.
ना मैक ये
माइनस वन
माइनस
पॉइंट
1.
लेकिन इसमें ई वैल्यू का कोई रोल नहीं है जो 0.002 है तो
एक मिनट पहले इस पे देखना. minus 1.299 ln of p1 minus. ये लोग p वैल्यूज का इम्पैक्ट को इसमें इग्नोर कर रहा है. तो now we have calculated that log odds is minus 1.299. How to convert this into a probability? So what you do is you raise both sides, you know, you raise both sides to the power e, right? So you multiply both sides and raise these by the power e. Right, now e to the power natural log of p1 minus p is nothing but p by 1 minus. And इसका calculate करो, e to the power minus 1.299, how much is it?
0.2726
कितना? 0.27. अब इसमें से p कैलकुलेट कर लो, बहुत सिंपल है। p इक्वल्स 0.2726 माइनस 0.2726 p। तो इसको यहाँ ले जाओ, तो p प्लस, तो ये हो जाएगा 1.2726 इक्वल्स 0.27, p इक्वल्स 0.2726 बाय 1.27, ये कितना होगा?
21.4.
21% या जो भी। Now if you want to see the impact of the slope coefficient on the probability, you change one independent variable by 1 unit. तो अगर जैसे बुक में ये ना, they've changed this second independent variable by 1 unit, तो इसको change करो and recalculate everything. So now we are going to recalculate. We are just going to change the second independent variable by 1 unit. So ln of p1 minus p equals minus 3.445 plus 0.332 into 3.2 plus 12.33 into 0.8 है, इसको बढ़ा दो 0.9 कर दो, प्लस 3.21 into 0.03, जितना भी आए फिर कैलकुलेट पी। So यहाँ पे देखना, यू आर रेजिंग बोथ साइड्स बाय द मैजिकल नंबर ही। रेज, यही मेन चीज है, रेज बोथ साइड्स बाय प्रोबेबिलिटी कैलकुलेट करो। मतलब वो 0.08 था x2, उसको 0.09 कर,
23.56%.
चलो 23 पॉइंट जो भी हो, तो स्क्वायर में लिखा है 23.57। तो बेसिकली ये है ना कि इफ यू चेंज x, इसका इसका ये होगा, इफ यू चेंज x2 by 1 unit, और इफ यू इंक्रीज x2, सॉरी ऐसे नहीं, if you increase x2 by 1 unit, then probability changes by 23.75 minus 21, that is 2.75%। तो ये इंटरप्रिटेशन है। क्लियर है? ये कोई प्रॉब्लम है गाइस? गाइस
No, sir.
तो अभी ओरिजिनल इक्वेशन में मेरे को बताओ, इफ x1, x2 and x3 all equal 0, then what is the probability of an increase in dividend? If x1, x2 and x3 all equal 0, then ln natural log of natural log of odds equals b0, which is minus 3.445। तब e to the power कर दो, p by 1 minus p equals e to the power minus 3। कैलकुलेट p, ये p को कैलकुलेट करके रखो, मैं 1 सेकंड में आया। गाइस आई एम बैक। हुआ कैलकुलेट हुआ? पी क्या है? हेलो?
3.1%.
तो यही सब है इसमें। पी कितना है? 3 पॉइंट वही। इफ if x1 x2 x3 equals 0, then probability of dividend increase is 3.09. और वही जो बाकी हमने कैलकुलेट किया। ठीक है, तो यही आईडी है। चलो गाइस, बाकी तो तुम लोग ये यही है इसमें। ये वी आई एफ सब समझा ही दिया मैंने। तो ये चैप्टर तो खत्म हो गया।